Thank you for coming out tonight. Not to keep pushing this ResMed infomercial, but I do tell everybody, all my colleagues, I've been here for over 4 years now, I tell them that ResMed is just a great company. It's the best company that I've been at. And I'm not just saying that, I really mean it. The culture here is fantastic. Top down, from the CEO of the company, the founder of the company, all the way down. Just a lot of great people. So if you are looking, we've got jobs. See Dave, or I guess
Well, let's introduce Amy.
Sorry.
Amy from our HR department, recruiting.
Hopefully she'll be here for a while. So for the presentation tonight, I'm going to go till about 8, take a break at 8, and then we'll pick up again. I don't want to go too long tonight, and I hope I don't bore anybody. So, and kind of help me better understand the audience, please raise your hand if you are familiar with Spring. If you've used Spring, okay, everybody uses Spring. Okay, how about Spring Boot? Okay, so about half the people that had their hands up originally. All right, so for everybody who's not familiar with Spring Boot, Spring Boot is a sort of a continuation of Spring. I think it's a very natural continuation that allows you to leverage all these benefits that come with Spring with modern techniques, modern technologies for scalable architecture. Right, and that's really where it's going. One of the things I think that Spring Boot and I'd say Spring 4 and up generally realize the promise of is that expression, convention over configuration, right? So Spring Boot is really all about convention and leveraging that convention and letting the mechanisms of Spring Boot work for you without you having to do a lot more work. So less work that you do, the more you can focus on other things. And that's not playing ping pong, although we do play a lot of ping pong here. So Spring Boot's, I think it's an ideal and efficient technology that really allows you to construct high-quality systems and high-quality microservices. Right? And we'll talk a little bit about what microservices are. Everybody's going to have different opinions. That's probably another one I'm going to do a hand raising at that point as well. But what's important to me is how can we make developers' lives easier? And if we make their lives easier, they can produce more and hopefully more and higher quality, right? They're not bogged down with the inner workings of the technology or the problems that technologies that they're trying to mesh multiple technologies together brings. So also on the lines of microservices, we hear a lot about containers, container strategies, container stuff like Docker, and some of the more traditional containers like VMs or Vagrant or what was the other one? There was another one we were looking at. So what does it mean? What does it mean to be on containers? I want to talk a little bit about that tonight as well. All right, so we're going to do a little hands-on lab with the microservices, or with, Spring Boot. Just kind of show you some of the ways that Spring Boot meet some of the microservice needs. And so I'm taking a big risk tonight. I'm putting up some code and compiling it, and hoping that it runs. I already ran, this is a Windows laptop, and I already ran into a firewall issue, so hopefully I got that resolved, and it's not going to happen again. All right, so let's talk a bit about microservices. So microservices is a software architecture style which allows you to compose applications of complex behavior are very small components. And I'm a big fan of the idea of composition. So instead of having a monolithic application, a monolithic set of services or classes or methods to try to solve maybe your very specialized business need, or maybe a complex set of business need, you break it down and decompose it into very small, discrete elements, components. And then you use another technology, an orchestration technology, to wire them together. Has anybody done that? Has anybody felt like they've done that in a position before? That makes, has anybody wanted to do something like that? I gave a talk, was it September? I think it was on Camel, Apache Camel, which is an orchestration technology. It's very, very good for this. And Christian Postis, right? That was Christian, yeah. I saw Christian Postis last June at the Red Hat Summit. Give a couple of keynote speeches. Want to learn more about Camel? So it looks like he's going to be talking about it next month. Java user group, I recommend coming back for that. Or checking out the video. The video of me from September, so yeah. It's always fun watching a video. Okay, so so as we see in some of these definitions of microservices, talk about small building blocks. Talk about the services are highly decoupled, meaning that if you have service A and service B, it doesn't mean that service A and service B can't depend on each other. It's that they don't necessarily depend on another artifact that you may be creating. They're very independent, very good. They can stand alone. They can up-rev in their versioning and not affect the other one. Right? We'll get in. I'm sorry, we'll get into some more of those. So on the question of microservices, anybody here who is working in a microservice architecture today? Okay. Are you leveraging Spring Boot? Anybody doing it leveraging Spring Boot? Okay. All right. So I hope I don't bore you guys. All right, so microservice architecture, MSA, you see Martin Fowler's written a lot of stuff on this. So in some of the description here that I'm taking from things that come out of guys from Netflix, Nginx, Fowler, WIKIPEDIA. So one thing is that services are easy to replace. And that really means a lot of different things, right? You could rev a service from one version to another. And you do that by actually changing your version that you're still running, like version 1, that stays live in your system while you bring version 2 up. And your clients that are dependent still work with that version 1. And then new clients will come in and say, I'm dependent on version 2, and they're going to rev up to version 2. Eventually, when you want to cut over, you can just remap everything that's going to version 1 to version 2. That may not necessarily be the right thing to do in the system. But the one thing that you never have to do is bring your entire system down in order to upgrade just a single component. And that's one of the things you want to try to achieve with microservices. Organize around capabilities. For example, like what's the user interface front-end services? So if you have a single web page application or JavaScript heavy application, Angular, that kind of stuff, it's going to go to a domain of microservices that are going to provide data for that page. Recommendation engines, logistics, billing. So you sort of group your microservices around those. And within them, you're going to have the ability to access data, store data, or do more complex business logic, like initiate some sort of very complex process. And going back to Camel being a really great orchestration for linking a whole bunch of microservices together, along with asynchronous engines like messaging servers and other external systems. So services can be implemented using different programming languages. Right? So we talk about here, we talk about Java, a lot of Java centric, but the microservices, very common microservice platforms, such as Docker, could be Node.js, could be any other scripting engines like PHP. Somebody said that, what are you doing? Microservices?
Actually, a mix of PHP and Java.
Okay. And so the language agnostic or the polyglot model of microservices is very common. And it really is going to be defined by the types of resources that you have at your organization. I know for us, we hire Java developers, so we really expect to be developing Java-based microservices. But if you're at an organization where you have more resources that aren't Java developers, I just don't recommend doing it in any Microsoft. So, and the architectures are symmetrical, right? So you have, it's almost like a peer-to-peer type setup with microservices. And it's not, rather than hierarchy, does that make sense or need to explain? So, oops. Okay, so microservice architecture lends itself to continuous delivery of the software development. So CD system, CD plans. Now I'm always curious to find people who actually work in a CD environment. So anybody currently working on systems with continuous delivery? 1, 2, okay. And how about just a CI, just have continuous integration? Okay, more people. So with microservices, it actually makes, it enables continuous delivery or makes it easier to achieve than having a full release cycle where you're generally replacing entire system and models. All right. So a lot of this has turned into a big lecture on microservices. Hopefully everybody's keen on it now. All right, finally, it's distinct from service-oriented architecture. So SOAs are not the same as microservice, right? So this is going backwards and forwards. Okay.
One of the things that is important to mention here, the difference between microservices and SOA, is first that SOA was more based on SOAP and these kind of technologies that we very quickly understood that are not sustainable. And the second thing is that SOA was based on usually on a message queue, where you have the main communication channel between services is a message queue, and that turned out to be really bad. It looks really good on the diagram, but very soon your system becomes a spaghetti ball of calls that don't make sense if you try to debug or understand the system. It looks good on the diagram, so architects plan it like that, but then for developers it's a mess. So microservices are based to be built like the internet. It's sporadic services that can scale and serve each other.
Thank you. No, yeah, you're right. And I was just like thinking some experience that I had with SOA-based architectures on top of enterprise service buses and how they grow wildly out of control and very ill-performed after some time. So a lot of people stay away from it. Plus, getting into that space is generally means getting in with some vendors who are trying to sell a product to the customers to get that working. And it's typically the only people who benefit from that are the vendors. So it is a good point to say that in microservices is sort of is putting the power back into the development community, the DevOps community. And so I guess last question is, of everybody in here, who has talked about a microservices architecture strategy at their organization that they're currently at?
Did it further than talking?
No, you haven't gone as far as did it, but you're talking about it, right? Okay. So one of the things, and I already mentioned it, 100% guaranteed, any discussion about microservices is going to bring up that. So if you want to see some real working example of microservice architecture and some of the patterns around that, you can get a lot of information through some of the Netflix blogs, very technical. Some of those start to refer back, and for me in researching this a while ago, they refer back and push back to Spring Boot. And that's kind of how you get there. Now, for me, Spring Boot was, just one of many different approaches and answers out there in a whole sea of approaches and answers. So it had to meet certain criteria. And for our organization, those criteria are not just about that it's Java-based and it's technology is based on Spring, but it has to have support. In particular here, support for test-driven development. Here's my favorite question. Who is currently at an organization where you follow strong test-driven development methodologies? I'm gonna bob you. So I'm gonna assume everybody else didn't raise their hands, does not follow test-driven development.
By that you mean tests first?
Test first.
Because if we write tests, a lot of tests, doesn't count.
Doesn't count. So you write tests after you've done the implementation, right?
I would say throughout, but not necessarily before the code is written for a method.
Got it. Anyone else, something like that? Yes.
Yeah, half of us write the test first, the other half is not.
Okay, so another thing to see is that it's not a standard that's enforced across the entire organization. So that's where you have in your CI systems, or as a part of your build process, there's standards that, hey, you've got to have this percentage of code covered, and we're talking 97%. That pretty much means you've got to have those tests written and developed. But sometimes it doesn't necessarily mean test-driven development per se. So following TDD is really about utilizing those tests up front to ensure that the behaviors you're expecting are going to propagate from the component that you're developing. So anyway, back to Spring Boot, very strong TDD capabilities. There's another need that we have is a behavior-driven development. Also one of my favorite questions asked. Something gave a presentation on behavior-driven development a few years ago. Raise your hand if you're familiar with behavior-driven development. Okay, oh good. Oh, that's good. There's technologies like Behave and Cucumber that allow you to use behavior-driven development. In our standard development methodology, we're developing web applications, we're developing RESTful APIs and monolithic WAR files. And we've developed components following test-driven methodologies. You develop a unit test, then you implement your maybe Spring MVC controllers that are in services and repositories, and you pass all your unit tests, and then you bring everything together and you deploy into a web container, and then you use your behavior-driven development once again to make sure that all your components are coming together properly. Like if you're a user logging into a website and you're going and you're selecting on this item and you want to purchase it and you enter your credit card information, blah, blah, blah. So that's, you're actually having to develop test components twice following that model. What's really keen about the Spring Boot is that you can combine both your unit level testing and your acceptance level or behavior level testing into one test cycle. I'm going to demonstrate that too. Okay, so some of the justifications and tooling. We're going to talk a little bit more about some other, especially configuration. Who has problems? I'm sure everybody has problems with deployment and configuration. This is where Spring Boot can really help you solve those problems, especially with following the convention method. Okay, so Spring Boot makes it easy to create standalone production grade applications. So they take an opinionated view, right? So basically say, this is how you do it. Follow this and you're good. You'll find that you will need to deviate from time to time, and there's help deviation, or you do a little experimentation. I'm going to show some deviations from the absolutes of their opinions, but the idea is that you follow those conventions and you're going to minimize the amount of effort you have. So it favors convention over configuration. All right, so can you read that? Spring Boot is, you can use Gradle, you can use Maven. I'm a fan of Maven, so we're going to talk Maven here. But there are many starter modules for being able to bring in certain technologies. So if you can have a Spring Boot application that just runs a CLI command line, and that's fine. Or you can have one that's going to run a RESTful web MVC for you. You bring in web module. If you want to talk to Mongo, you bring in the Spring Mongo module. If you want to talk to JMS, actually I think JMS includes automatic. If it detects that you want to talk to a JMS or have a JMS connection manager, it'll automatically bring in the JMS stuff. So creates standalone Spring applications, which is basically gives you all of that framework for being able to create a standalone application, release passive configuration, bootstrapping all of your frameworks and components. It's a lot better than just writing your own. I mean, it's even easier than writing your own Java with just the main method and parsing your arguments and trying to figure what's going on. Spring will give that to you automatically. Automatically embed Tomcat, Jetty, Undertow in order to allow you to deploy a Spring Boot based web service in its own container. We'll see that. Start palms, automatically configure Spring whenever possible. Okay, so there's about 9 different ways to inject configuration information into a Spring application. We're not going to go over those. We're going to narrow this down to just a few. But this is also another one of the important criteria I talked about with not just with tests, is that it's configuration. How do you provide a simple, non-convoluted means of configuring your application while you're developing it as a developer, and you've got resources that are either local or very limited as a developer. So how does that get into the CI system where it's tested properly? How does that get into your test systems where it's configured properly? How do you get into production? Right? You got to think about this configuration scheme. This is one thing I see. This is something that tears development groups apart, and DevOps apart. It makes people enemies. It gets phone calls in the middle of the night. Right? You guys, I mean, look, I see a few smiles and nodding heads, but this is the one thing I see that just absolutely wrecks the entire organization, is not being able to configure an application. Here's another thing that wrecks is that the development team is so busy getting those features together, getting that system together, getting it out, that they really don't have other tooling around it, right? And that tooling usually comes as an afterthought. Or if you're a more mature organization, it will come as a forethought, but it's a lot more overhead. So tooling like health checks and metrics, also being able to introspect the Spring context in a running Spring application. Those are all key tools that that help your app support organization, your DevOps organization, you when you're being called in as a level 4 for debug support. So that no code generation, we get away from Spring XML. Okay? We asked a question before about everybody working on Spring. Who's still working on Spring 3? So everybody else is at Spring 4? Hopefully not Spring 2, right? Have you guys, is anybody still using XML for your Spring? No? Everybody's moved up? Okay, good. You guys are all ready. All right. So real quick, I just wanted to just give you a real simple view of what it would be like to use Spring Boot to create and deploy a service in a container like Docker. So let's look at each one of these round rectangles like they're a Docker image. We have multiple service A's, multiple service B's, multiple service C's. And so Docker and some other technologies like Kubernetes might automatically configure those services and their locations and their IP addresses, and ports, and routing through its router technology or load balancer. Go out and talk to F5 or go out and talk to an Nginx and say, hey, if anybody wants service A, here's a virtual IP for it, or here's a DNS for it. I'm going to route it to these different service A containers. I'm going to use on that container, the Spring container, and it has a health check. I'm going to call that health check and make sure that that service is continually live before I give anybody over there. If it's not, I'm going to route them to a different service when it is healthy. When you look at the Netflix has a much more complex mechanism for how they short circuit and restart services. Docker or OpenShift, Red Hat product, has a very complex mechanism for making sure that Docker images, or the number of Docker instances for a particular service are always running. But they're really based around this one very simple sort of architecture. You got a whole bunch of services in their own containers. You load balancer, your client's going to access them. That's it. And then there you go. You got a Netflix. Okay. So, were there any questions? And kind of got a little heavy one way, heavy the other way. Yes, sir.
In the previous slide, slide number 2, 12, I mean. So, in slide number
12?
12, yeah. So, there are like 2 boxes for green service A and green box.
Sorry. Okay,
So,
there we
there are
go.
like 2 instances of each service A, service B, and service A.
Yes, yeah. Was that the question? I was simply trying to demonstrate that you'll have multiple instances of a service spread out over your production hardware to try to provide maximum amount of performance. Also reliability, so one can fail. Like if service say, I didn't show any dependencies here, but when you look at Netflix, one of the things that it does real well is show the dependency graph from one service to another. So service A might be dependent on service H, which could be dependent on service M. Service M could be a database server. If any one of those fail or short circuit down the track while you're in the middle of a transaction, that will propagate and cause services to shift over to another dependency chain and try to minimize the ultimate failure back to the client. Okay? All right, so I want to take a 10-minute break and then we'll get into sort of look at some code, live demo. We can reconvene in 10 minutes, which is 7:55. Great, thanks.
Okay, restrooms are located in the back center section here, and by all means, we still have the lottery at the end of the show.